Okay, nothing, right? Okay. Then from here, when you have nothing else to analyze, that's where move on. Okay. So what did I say? Do not analyze the dots and do not analyze the crosses. Okay. Only analyze the 150, the arrow, the one that look at like an arrow. Okay. So if once you realize that you have nothing to analyze, let's go to the next view. Okay. So I'm going to draw the next view now. So the next view. Okay. So the next view I'm going to draw is X. So the next view that I'm going to draw, this will be my X, and this will be my Z, and this is the rotation about Y. Okay, right. So now where we are viewing at is we are viewing at the plan view. I repeat again, we are viewing at the plan view. So at the plan view, the drawing is easier. Okay, the drawing is more simple. So we will have, yeah, this is the log, this is the built-in. So we have 4, 6. Okay. Yeah. Okay. So again, you put in the position of your element. So now what you draw now, this is your element H. Right. Over here by the side, this is your element K now. Okay. Then you draw the position of your neutral axis. Okay. So this is your neutral axis. Okay. And then you have a round thing down here. Okay. Right. So this is the plan view. Then you start putting in your forces. Okay. You start putting in your forces. So you will have a force acting down here. So this is at, oops, sorry, I'll move down so you can see. So this will be, if you look at your question, this is your 50 pounds, right? And then you will have your 2, 4. Over here, this is your 150 pounds. Okay. And then you will have 200 pounds. Right. And then you will have your 150 pounds. Okay. So you have to take note for this case, you have finished analyzing your 150 pounds already. So your 150 pounds is not going to you're not going to get any new information from your 150 pounds. Okay, so you highlight your 150 pounds, you have analyzed it already. Okay, now the next thing we're going to do is we are going to look at what stresses will be induced. So you know that we are going to have our shear stresses, right? So we are going to do shear stresses. Okay, positive is going up, right? So I mentioned about shear forces. Now, this is not static analysis, yeah? I did not say that it's equal to 0. I repeat again, this is not static analysis. We are not doing static analysis. By no means we are assuming that the summation of forces is equal to 0. We are seeing what stresses or what forces are acting on the element, okay? So now, Vz, okay? So I'm going to do summation about forces in the Vz direction. So going up is positive, summation of forces in the VZ direction will be equal. So any force that's going upwards will be positive, downwards will be negative, right? So this will be 150 plus by 50 minus by 200. It happened to be equal to what? 0. Okay, 0 pounds. So 0 pounds is good news, right? Why good news? Because we thought we are going to calculate a shear is equal to VZ over IYY QY divided by T, okay, divided by T over here, and this happened to be equal to 0. So it's good news. So element H and element K, based on those forces that we see, are not going to have any all of a sudden any shear stresses based on the 150, 50, and the 200. Okay. Then the next one, we're going to take moment. Okay, on element H. So we're going to take moment now. Okay. Now I call clockwise to be positive. Okay, as I said, this is not what? This is not static analysis. I decide to call clockwise to be positive. Okay. So from here, we're going to take summation about moment in the y direction. Okay, and this is from element H or NK, right? Okay, so the 150 is going to be anti-clockwise. Okay, so it's minus 150 multiplied by 4 minus by 50 multiplied by 10, right? And then plus by 200 multiplied by 10. Okay, so this also 150 times 4 plus a 50 times 10 minus 200 times 10. So it's good to 900 pounds, right? Positive 900 pound inch, and the rotation will be going this way, right? So now you know the rotation, the moment that is going to induce by the 150, 50, and 200. So the moment will be acting this way. So this is your moment about your y-axis, right? So this is in tensile, compression, right? And then how the structure will bend? The structure will bend this way. Right? So when the structure bend that way, right? So this is the deformation. It's confirmed that it's going to be what? A bending moment, right? Smiling face or sad face. Then from here, you can, from here, you can say what? Element H has 0 stress. So you're going to apply stress X, right? I'll write this out for you. Is equal to My over Iyy multiplied by Z. Right, so from here, you know that element H will be equal to what? Well, element H will be equal to 0. Right? It'll be equal to 0 because it's at the what? At the neutral axis. Okay. And then element K will be equal. So if you look at element K, it's going to be under compression. Okay, so you say the element K will be under compression. Now, this analysis bit is important because at the end of the day, right, you will appreciate all this that we are doing now, because at the end of the day, this is a very long problem. Okay, so whatever things that you are analyzed now, write as much information as you can, or not, you will get really, really, really lost. Okay, I got lost before. Okay, I'll tell you that I got lost before. Okay, so from here, anything else to analyze? Nothing. If you want to analyze the 150, you write this. Oh, 150 is Px is equal to plus by 150 pounds. If you want to do it, it's up to you. Okay, but when you write that, right? When you write about px, is the same as what you have written up here. Px is also 150. Let's not waste time. Okay, we have finished analyzing it. Move on. Okay, it's exactly the same as where my cursor now is. Okay, it's the same. Okay, so this is not necessary. Right. Then we have one more view. Okay, we have one more view. The thing that's querying us is we have to make sure that we look at all three views, right? To make sure that the analysis is structured is complete. Okay, if you don't view all three views, you don't draw all three views, you're gonna have problem. Okay, now the third one. So the third view that I'm going to draw, okay, the third view that I'm going to draw now. Okay, so I see something on the chat. What do I mean that it's not static analysis? Because what I mean is that I did not say that summation of forces is equal to 0. Okay, I did not use that criteria. That's why I mean that it's not static analysis. Okay, right. And then, okay, thank you. Okay, I've answered the other one already. Okay, so now we're going to look at another view. Okay, so another view that we're going to look at is going to be this view. Okay, so this is going to be my y. This is going to be our z, and then this is rotation in the x. Okay, so we are viewing the front view now. Okay, okay, so this is I'm going to draw it thicker because I need to write a lot. Okay. Okay, so this is where that's why it's so important to draw all this. Okay, this is where your shaft is. Okay, right. These are in fact dotted line. Okay, because we are looking at the front view. The next thing that we have to draw is we have to draw where our element what. This is our element H, and this is where our element K is. Right. It's important to draw this. Then you know what region are you interested in. Okay, and then you draw a green. Now your neutral axis is a green dot, right? So I'll draw it big. Right. Okay, then we draw our forces. Okay, so we have 200 pounds, right? And then we have 150 pounds, right? Then over here by the side, you go and see the 150, and you're also going to see the 50 pounds. Okay, anything else? That's it, nothing else. Okay, then you highlight what you have analyzed. I've analyzed this. I've analyzed this. In fact, we have also looked at the 200, but the problem with the 200 is what? The 200 also has a perpendicular distance, right? So the 200 over here also have a perpendicular distance. Now the question is this. Is it a moment or is it a torque?
In this case, it's a torque.
Why?
Because the distance is from the neutral axis and it's
Moment.
causing a rotation.
Yep. Moment is also causing a rotation.
Yeah, but it's causing a rotation around the neutral axis, whereas bending
Yeah.
moment.
So now the thing to analyze is this. If the 200 pounds is X, will the neutral axis move?
No.
The neutral axis won't move, right? The neutral axis will fix.